Thank you, chairpersons. Good morning, everybody. Good afternoon, I think. So, as Professor Maqbul Sahab and Dr. Bisaina very well said, that this is a new dawn at SKIMS. We know SKIMS has done reasonably well in medical care. There is no question to be raised about that. And also good in imparting medical education. But where the problem has been over these decades, whatever the multiple reasons, has been that research has not taken the front seat. It has been on the back burner. So I realized these 2-3 events to be started at SKIMS when I came from AIMS New Delhi. I, as a faculty member, new faculty member, underwent an orientation program at AIMS. I said this in the morning, and that is how I thought that is very important, because that made my life easier there, even though I was trained earlier there, but sometimes some people who come from other places, it becomes easier. Second thing, also you end up in eulogizing some important faculties. As you see in the morning, Professor Parvez gave a talk and he showcases his what research is. Many of you must have seen that how you make your own trajectory. So that is the idea. So we also started a faculty research day here, as it is done at AIMS New Delhi. So we also have a clinical orientation program for new postgraduates, DM scholars and MCH scholars and PhD scholars. So we have been doing for last 2 years a Department of Clinical Research, and this time we have actually done this program jointly with Medical Education Unit and Department of Clinical Research. And as you know that several topics, several speakers are there. Here I am supposed to talk specifically on the research question. Why we have kept this topic is that research question is the most important thing which will actually address or which will challenge you now. I know that at this institute there is a program at work that you don't become guide immediately. But I joined AIMS New Delhi, I became PhD DM guide immediately, because they have a very nice program that you become guide immediately. But what I suggest for you, when I have a faculty at SKIMS, I try to be co-guide of many people. Co-guide a PhD and scholars and others. That is how you start getting exposed to handling students and guiding them in research. You will not get students for 8 years now. So we see as subject research, I initiated this program that we should give intramural research grant to the young faculty. So there is a specifically some amount of money actually kept from research money what institute has for you only. So when you are now joined, you should start thinking of a research question and utilize that money, and 2-3 years down the line you have a publication for your promotion, then you are actually have some data to present in conferences and have some data to invite extramural grant. So that is a seed money which we are going to give you in next few months. But for that also you need to present a very nicely designed research protocol. And the protocol starts with a research question. So what is this research question? First of all, we know that research is a scientific way of, systematic and objective way of offering solutions. It is the problem. So it is also an endeavor to discover, develop and verify the existing knowledge. I understand, sir, that if we were knowing that what we have, then we did not do research. So the facts are clouded by or surrounded by many unknown things. Those unknown things demand research. So redefining a problem, formulating a hypothesis, formulating objectives, collecting, organizing, evaluating data, making deductions, reaching some conclusions, testing those conclusions, all this whole is a process of research. Now, why do we do research? Research has multiple benefits. It offers benefits to everybody. For example, it solves many unsolved problems of the humans, or even for that matter, all life in the planet. It gives intellectual joy to an individual. It serves society. It gives you respectability, satisfies your ego. Sometimes you get job, promotion. But more important is that it gives an institution gets a name, and this institution offers many benefits to the community as well as to the total knowledge pool existing in the world. So if we see clinical research, the research everything is similar, but clinical research has some, it is sort of a train of events. I don't want you to get clouded or confused because of so many events, but I will tell you that it starts from preclinical studies or animal research, your cell culture or animal research, and then you may have case series, case reports, clinical trials from animal bench research, and it can get translated into the human clinical research. Here you can have observational studies, phase 2, 3, phase 3 are even RCTs, and they can even itself go through phase 3, 4 trials into clinical practice. So, for example, a typical example of a drug, we have dapagliflozin for diabetes, was tested in animals. A case report because those animals who were taking this drug had glycosuria. Subsequently, it was tested in animals, then it was tested in humans in phase 2 and phase 3. Then now it came into clinical practice. Today we are using this drug very well for not only diabetes, for cardiac benefits and so many of them. So this is usually a journey of the clinical research, but when you end up with services to humanity, outcome, health outcome, and other things, there come guidelines and meta-analysis, you always end up in setting up new set of research questions. So if I start with one question here, then dapagliflozin, can it be used for diabetes? The data has now reached to a place. Now can we use it for cardiac failure? Can we use it for so many kidney disease, so many other conditions? So this is how new questions come up in this research process. So we know, generally we have been told in MBBS or MD that you have exposure and you have disease outcome, but studies as the research goes, it becomes more complicated as days on. So research strategy is basically starting with a broad inquiry with a hypothesis, specific aims, then you have not many questions which are coming out of a solution of a basic research question. So research question is a problem identified by research for which he wants to find the solution. So where do research ideas come from? We know we are doctors, we are clinicians. So suppose there is a social scientist who goes to the society, he finds a lot of issues existing there. So we are doctors, we sometimes do a journal club, or we read a journal paper, we do Cochrane review or any other research. We find at the end, conclusion of the research paper is that there is an existing data showing this. However, more studies are required to give the answer to this question. So that is the underlying, bottom line of the paper is a new research question. So when you do ward rounds or you are in OPDs, you find a particular patient doesn't respond to a particular treatment, or a particular patient, you incidentally give a drug for some other thing, you get a benefit in other clinical condition. So if you are very vigilant, very open, very honest, you might end up formulating a research question there. Or you have patients, sometimes students give you questions, or you go to a conference when you are delivering lecture, a naive student comes and asks you a question. Many good scientists worldwide, they jot down those questions and they go back to their research group or the lab and they start that I was asking this question, let us work on that. So they sometimes could be $1 million questions what are asked by very people who are not biased, because when you go into some research area, you get biased. So sometimes you discuss with colleagues, discuss in your department, discuss with your students. So you get ideas. You are over a lunch or a coffee, you discuss across various streams of medicine, you get a research question. That's not like, instead of focusing your research on something irrelevant, it is always good that we should develop a culture, discuss among yourselves that you are a junior person, you ask a senior person, hey, what is this? And more importantly, you can ask the worst critic of yours, that I want to do this study, this research question. He or she will critically look into that. So sometimes discovery of new tools, suppose you have imaging tools, you have gadgets, you have other things, while you use them, you sometimes find new things there, or new drugs, you find new things. So, where do these research questions come from? As I told you, that it's an iterative process. From your joining today, you might accumulate research after 20 years, some research question. So it is not just a light bulb phenomenon, you got a research question suddenly in the mind. It is basically the outcome of so many processes, so many clinical activities which you are doing on daily basis. So being an iterative process, you need to be very active in jotting out some unknown facts. But a research question should be what is called, it should have certain characteristics. We abbreviate it as finer characteristics. Internationally used abbreviation. It should be feasible. Feasible means, suppose I think of doing a research study and develop a research question of going to the Mars, and I want to see whether life is there and get a sample due to microbiology SKIMS. And you know, it is not feasible. Director Saab will laugh at me, how will you reach to Mars? Then is our microbiology good enough to do that sample? So feasibility is the first thing. Then it has to be interesting. Interesting means when you say this question to somebody, he will say, what then? How does it matter? My food doesn't bother, you are saying this question. It should be appealing, interesting to the other person, that person should think for a while. No, this question is worth it. This boy or this girl has something in mind, it is rational, it is interesting. And then it has to be novel. Novel means, as Parvez Saab was telling in the morning, many times what happens is that an idea comes to you in the ward, and then when you see literature, it has already been done and dusted. That's okay. You got an idea, that means your brain is functioning. But some people have done it and it is not actually now appealing. However, there are anecdotes. I'll give example of Banting and Best discovered in sleep. When Charles Banting, when he got Nobel Prize, he gave a actually disclosure. He said that there were 50 papers available on dog pancreatic surgeries, creating diabetes and giving extract. They all had given negative results. He says that I thank God that I was ignorant. I have not read those 50 papers. I thought mine is the first, so I did this experiment, he succeeded. Those 50 papers would have biased him. Now those were days when we did not have internet, we did not have information technology. Today what is the problem? If I tell you a research question, some of you must be this time also seeing in your mobile and checking the final criteria whether it is correct. So on the background you are checking these things, and sometimes literature biases us. Professor Sharik has done a study in diabetology 10 years back. I think now why should I do in Kashmir, because it is already done. Sometimes if you are skeptical about, you should question that already existing literature also, then you might improvise, because literature is sometimes biasing your mind also. So you should know that most of the times you will not attract funding, your project will get rejected, your guide will not accept it, others will not accept it. But once in a while, an idea which has been searched may not be correct. That is an exceptional scenario, but it should be novel. If you want funding, if you want your paper to be published, if you want this to be accepted by your peers. Then ethical, we know ethics, it will be spoken to, that whatever research you will do, it has to be ethical. You cannot give a drug which is not safe for a human being and for the sake that you want to publish a paper. So Professor Magbul Sahib is here, he is always guiding our ethics committee here, he has been in various capacities here, he will tell you what ethics actually means. I will not divulge in that, but it has to be relevant. Relevant means what? It means it has to solve a problem of a mankind in general. Your local population, for example, Parvez Sahib was saying thiamine here, so we have certain primary cancer here. It is locally relevant. Why don't we work on that? Rather than working on a thing which will not pay any dividends to us and our population. So, these final criteria. What are the characteristics of a good research question? So, it should be clear. It should provide enough specifics that one's audience can easily understand, and without you needing to explain. What is your audience? When you have a research question, your audience is, suppose you put an intramural grant to us, I am reviewing, our team of reviewers is there, I am your audience. So I should see the research question, I should not need to call you. Hey, Dr. X, you have written this research question, can you explain to me what you want to know? It should be so brief, short, but it should be very clear. Same way, when you put research proposal to NIH or ICMR, the team of investigators is seeing that, reviewers are seeing. They should get a clear idea there only. They did not need to send you an email and for clarification. So it should be very clear, specific to the point. It should be focused, means it has to be narrow. You usually have clear-cut research proposal online. You have a research question 10 words, 20 words. You cannot write 500 words. So it should fit that space. Then it should be concise. So obviously that is the way we say focus, it has to be brief. Then it should be in that conciseness and brevity. It should have a complexity too. It should not be too simple, yes or no. So our research question and yeah. It has to have complexity within that brevity. What does that mean? Suppose you have a question, it should have woven some idea behind that. So I'll give you some examples of these for study. And it should be arguable. Arguable means if you debate, then you should have a hypothesis behind it. You should have actually some rationality behind it. Why do I want to do? For example, I will say that I want to say do MRI or looking at a lesion inside the heart. So conventionally it is not being used. Okay, you say if I use MRI, it will help me in this question. So it is arguable. And research question should have a format. This format is internationally acceptable. It should have T-card format. The new faculty, please jot down these two things, final criteria and T-card. Because if you are now planning a research question for intramural grant, or you want to be co-guide and give a thesis to a student, now you put this, jot down these and try to experiment these. You have to revise them, then only you will actually refine a question. So what specific patient population of interest you are taking? So population. Population always doesn't mean patient. Population means whatever another things you are actually examining. So what intervention you are doing? Intervention again doesn't mean only giving drug or doing a surgery. Interventions could be many ways. So you have, suppose there is a social intervention, suppose you are doing a pathology sample, you are doing radiology sample. So intervention, what you are doing is that should be there. Then what is your comparison? So if you are devising a new technique, if you are devising a new drug, new surgery, or saying a new method of diagnosis or new method of examination, you have to say what is the gold standard with which you are comparing, or what has been the alternative, or with what you will compare. Sorry. Sorry. Go on. Yes. So, what should be measured? You must have known that there is something called objective and there is something called outcome measure. So, and there is something like outcomes of the study. Outcome means overall, if you do some study, let us say we give antihelminthic to a population and we say that there was eradication of SKIMS in that village or some population. That is an outcome of the study. Outcome measure is that we have given levanesol and we have measured the egg count in stool. If there is less than 5 egg counts in a field, we say that it has been eradicated. So that is the outcome measure. So you have to measure a specific thing. So that should be actually also in the research question. How will you measure? Then it has to have a time frame. Time frame means your research question will take 1 year, 2 years, 3 years to answer. Suppose I will see what is the outcome of cardiac outcome of using a drug SGLT2 inhibitor. So it will take me 50 years. Okay. So whether I will be in the academics, whether you will be there, whether that patient will be there. So you have to say that in specified time I will have this research question answered. So that has to be there. Now there is a step up process or step down process in having a research question generated. So you usually choose a topic in research and you have to do some preliminary search. You go to PubMed, you see meta-analysis, or you see whatever data is available, or you ask from the people who are working in that area on conferences, or you write emails, you tell them that I want to do study, what is the available data? As days pass on, the literature is becoming very easy. I know in one of our conferences there was one Dr. Rai, he died now, Indian person, who had a conference in AIMS, AEPCS conference, and one gentleman from UK, David Abbott, gave a lecture that I gave testosterone to monkeys and I induced PCOS. So that paper went into NEJ. So Dr. Rai got up, he was from AIMS, Indian fellow. He said, "You gentlemen, what are you talking? I did this in 1962 and you are doing this in 2011. So he told him, no, I searched literature, nobody has done it, it is my first paper. So Dr. Rai just sent a boy to the library and got a Lancet of 62 because those Lancet issues were not on the PubMed. Now all these databases are including old literature as well, new literature as well, even small theses, even small libraries are on these databases. So it becomes very easy to search literature today. But still then a lot of literature could not be on PubMed only. There are many databases you have to approach to find whatever relevant literature will be available on your topic. Then you consider audience, that when you have done literature search, you know, yes, my research question has not been so far attempted, people have not answered, or if they have tried to answer, they have not conclusively reported that. So you consider your audience, then put it. Then you start asking questions to yourself or make your peers or other people to ask you questions, and then you re-evaluate this question and go back. So as I told you, it is an iterative process. Sometimes you may take a year, 2 years, 3 years to arrive at the final research question. So there is this pyramid accordingly. So you go to, suppose, Cochrane database or other varied databases, there are a lot of databases who do research, and there is very small data will be available in this form, which is conclusively answered. Most of data will be from expert opinion, background information, case reports, case series, case control cohorts, and most of this information, unfiltered information, is available. But if you are lucky, you have information which is filtered like this, very nice. It will become easy for you to generate a research question and also generate a hypothesis and design a study. So sometimes textbooks and medicine have a lot of dogma. Suppose we say that if spleen is tip of spleen is palpable, it is 500 gram. If it reaches umbilicus is 15 gram. We have been told, I don't know whether that is true or not. These are dogmas of medicine. So maybe a radiologist takes this question, but is it really good? We were told that if your thyroid one lobe is bigger than your left thumb, this distal phalanx of thumb, so you have thyromegaly. Who had seen this? How do you know that? Now ultrasound, MRI, other modalities available. We need to see whether that was correct or not. So we know that we have several types of studies, whether they are observational, whether they are comparator, analytical, descriptive studies, whether you have experimental studies, non-randomized or randomized control studies. You will have research question accordingly designed for these studies. So, inshallah, if we have a very small group focused meeting with all of you interested ones, we can individually see which research question for which study can be generated. As Dr. Inam said, each study type will need a different type of sample size. Now I will give you an example. Suppose we have a question about the effectiveness of intervention of outcomes in some sick patients or sick patients suffering from some condition. These are usually the questions which we ask, for example, COVID-19. So we have to do an RCT. For example, remdesivir was used or even vaccine was used for prevention. So you have to do RCT or even a prospective study. Suppose you have a question about a procedure, pathology, FNAC, or a genetic test of that fluid from the thyroid gland. Suppose Dr. Romana is doing FNAC of thyroid gland, and then we do some marker in that, and what is its sensitivity, what is its specificity, a diagnostic test. So those type of things you need either a cohort or an RCT. So similarly, for etiology you need cohort studies, sometimes you need qualitative, quantitative studies, and the research questions will be accordingly designed. So I'll give you one example of our study. Suppose we have a research question that what dose of vitamin D is required to achieve optimal level of 25-hydroxy D in India. So there are a lot of studies, meta-analysis, that people give. Suppose you have vitamin D duty, we give 60,000 6 weekly, some give monthly, some give 6 lakhs, orthopedicians give 6 lakhs every week, and then they come with toxicity to Dr. Muzaffar. So there is no protocol. The Indian guidelines, there are no guidelines what dose is required for an Indian adult. So we try to seeing that paucity of literature, seeing that there is no question, no answer to this question, we put this question. So we designed a study, 4-hour study. We give 600 international units, which has been actually suggested by ICMR. ICMR says give 600 units daily, that is good enough. So some study use it we use usually 6 lakhs per month, some of them. So we use that as another arm. Then we thought of our own experience, we will give 1,000 or 2,000. So we did this study for 6 months, and we kept a hypothesis, that null hypothesis. You know, there is a hypothesis usually null, means that we know there is no difference between these doses. Whatever dose you give, you will achieve the same level. So that was the hypothesis. So alternative hypothesis is no, one dose will be better than the other one, or one dose will be inferior to the other one. So what we did, we found that the 2000 international unit daily is bringing the optimal level in Indians, which is again is the published literature. Indian, the ICMR says 600 only. So we are going 3.5 times higher. Even US data, sir. So that type of research question in a reasonably done study, RCT double blind, we could get this study. It came in a small journal, British Journal of Nutrition. But what it got, it was selected as a paper of the year by Cambridge University. The idea is the research question, although very common problem, vitamin D deficiency, but the research question in this very common problem was, we had devised it uniquely, it was very relevant to our population, and we had put a robust methodology into it. That is how it reached to this level. So, now leaving these Cambridge University and publication aside, now you see what is its implication for this 1.5 billion population. 70 to 100% Indians are vitamin D deficient. Even in this hall, almost all of us will be vitamin D deficiency. The implication is that we know that if we take 2000 units international daily, that is the answer. So that is one of the examples. Now sometimes that was a single research question. Now sometimes you can have studies, especially in tertiary care institutions, you may have multiple.
Can you please try to conclude now? It is already very late.
Right, sir. So you have multiple research questions in a study. So suppose, for example, same study, we have put in the cutoffs of vitamin D, what is its impact on other tissues, and so many. So we have nested, that's called nested study. So you put many questions into one important big study. That another example we give, that we have a PCOS course where SKIMS is fortunately the coordinating center. So we have nested almost a dozen questions. You can see genetics, environment, preventive, therapy in this study. So this comes up, you have to graduate. You first do a very simple study with one question, then you go up 2 questions. So you go up in the ladder and find it. You can have all this circle completed. So accordingly you generate hypothesis. I told you what is the null hypothesis and alternative hypothesis. And we come back to that picture that while you reach to the solution of a one, suppose we found the real answer of vitamin D requirement per day, now it generated 5 questions. So new question set comes, and that's how research has to be collaborative. I do one question, I solve one question, 4 questions arise, 4 of you solve that, 16 questions arise, 16 of you follow that, and it is a collaborative effort, and it is an iterative ongoing process. So I conclude that research question, before research question you have to do a thorough literature survey, and after that you learn about the trends in the research, and once you have that research question, discuss with your mentors, experts, collaborators, and then you see that your question has finer criteria, qualified. It also has Picard format. When these two formats are, then you see it can generate a nice hypothesis. One is that hypothesis there. Then you say that this research question can give very robust objectives, and then you have a proper methodology in place to answer that research question. Thank you very much.
Thank you, Professor Ashraf. It was an excellent talk. Immediately advisor. Since we are running short of time by more than 1.5 hours, and I expect a lot of questions from the audience, but we would be allowing questions at this time, so any question we can discuss it during the lunch break. Thank you, Professor Ashraf.